Hello and welcome students. Now we will take question number 8. This one I will solve. Here we are given I write the given function as y. So let y equals to sine inverse of 4 raised to x plus 1 over 2 upon 1 plus 2 raised to 4x. This is very interesting problem and easy as well, which makes this problem important. All easy problems but interesting problems are important problems. So here there are two laws of indices that we are going to make use of. The first one is, a raised to m into a raised to n is a raised to m plus n. So we will make use of this law, but from a right to left, we will make it this way. And secondly, there is one more law of indices. If you have a raised to m raised to n, then it is a raised to m into n. Okay, so this one also we will make use, but then we will make it from right to left. So let's begin. So first of all, what I understand here is this function is sine inverse of, it is sine inverse function, and this is not x, it is f of x. So I will not differentiate directly, otherwise this will become a very troublesome. So I write here, I try to simplify this. I try to simplify this particular function. First, I will try to simplify, and for this function, I will try to get a simplified function. Simplified function. I will try to get this simplified. So here, the next step I write as sine inverse of 4 raised to x by 2, 4 raised to x, I'm sorry, 4 raised to x into 4 raised to half. So 4 raised to half will be root of 4, that is equal to 2. And here I write 1 plus 2 raised to 4 the whole raised to x, and the bracket is closed. You understand? I have made use of both the identities, this and this. Okay, next. Now next step, what I do is I write this as sine inverse, and this one here is square root of 4, which is 2. So I write this as 2, and this is 4 raised to x as it is, and 1 plus, look at this part. Here inside the bracket, I have 2 raised to 4. What is 2 raised to 4 equal to? 2 raised to 4 equals to 16. Okay. And if I ask you students, what is 4 raised to 2 equal to? That is also 16. So for 2 raised to 4, can I write 4 raised to 2? Yes, we can write. So the next step here I write is 4 raised to 2 the whole raised to x. Okay, this x I am keeping as it is. This x is where it should be, exactly the same way here. Okay, so I have not done anything to x, only thing I have done is 2 raised to 4 is equal to 4 raised to 2, so I have written that. The next step I get is sine inverse of 2 times of 4 raised to x, 2 times of 4 raised to x divided by 1 plus this 4 square the whole raised to x can be written as 4 raised to x the whole square. This is another law of indices, which is actually corollary of this only. It is corollary of this part itself. For example, I'll show you this. This is a raised to m the whole raised to n, which is a raised to m into n. Suppose I write here a raised to n the whole raised to m. Then what it would be? It would be a raised to n into m. So what you see? You see that whether power m is inside the bracket and n is outside, or n is inside the bracket, m is outside, in both the cases the RHS happens to be same, as m into n is n into m. So for first and second, we notice that RHS are equal, so the LHS also become equal. So what we understand is, if we have a raised to m the whole raised to n, this n and m can be interchanged. Okay, so this I right here, so this will become sine inverse of 4 raised to x square. I have got this. So next what I follow here is, look at this, this is my y. When I see this expression reminds me one basic expression which I had taught you in the earlier videos. What was that? If you recall, 2x upon 1 plus x square, whenever we substitute in this expression, we put x equals to tan theta. Why we do that? Because if we are putting x as tan theta, this particular expression will become 2 tan theta over 1 plus tan square theta, which is equal to sine of 2 theta. This is equal to sine of 2 theta. Got it? Now, as I have here x, as in this expression, I have got x. Here, I have got 4 raised to x. You will all agree to this? Yes or no? This is 4 raised to x. So here, in order to get this expression changed into this formula, I have to put x as tan theta. So in order to get here this expression, if I want it to change into this formula, I will have to put 4 raised to x as tan theta. So that is my next step. What I will do, students, I will write here, for this I write put x equals to, I'm sorry, put 4 raised to x equals to tan theta. Now when I do that, I will get y equals to sine inverse of 2 tan theta over 1 plus tan square theta. Tan theta square is same as tan square theta. And what is this? It is sine 2 theta. So I get y equals to sine inverse of sine 2 theta. You know the result, sine inverse of sine 2 theta will be 2 theta only. So y equals to 2 theta. Now, once you reach here, what you will have to do is you will have to resubstitute theta. Why? Because the given problem was in x. See, the given function was in x. So, when you are differentiating, you will have to resubstitute theta. If you do not resubstitute theta, you are having here y as a function of theta. You are not supposed to differentiate with respect to theta, because the question was differentiate with respect to x. So what is theta? Theta you will get from this step where you had substituted 4 raised to x as tan theta. So theta would be tan inverse of 4 raised to x. So next step you will write, therefore y equals to 2 times of tan inverse of 4 raised to x. 2 times of tan inverse of 4 raised to x. That's it. Here I will differentiate. Now we can differentiate with respect to x. See, now we have simplified the given function to a great extent, differentiating with respect to x. So d by dx of y equals to d by dx of 2 times of tan inverse of 4 raised to x. What is next step? We will write this 2, which is a constant, we will write it out. So 2 is out, and we have d by dx of tan inverse of 4 raised to x. D by dx of tan inverse of 4 raised to x. You know what is derivative of tan inverse x? 1 upon 1 plus x square. But is this tan inverse x, students? No, this is tan inverse of f of x. So its derivative will be 2 times 1 upon 1 plus 4 raised to x the whole square into d by dx of 4 raised to x into d by dx of 4 raised to x. What is d by dx of 4 raised to x? It is 4 raised to x log 4. D by dx of a raised to x is a raised to x log a. So this is 2 upon 1 plus 4 raised to 2x. This 2 will multiply this x. The power of power, they multiply into 4 raised to x log 4. So the final answer you get is dy by dx equals to 2 into 4 raised to x log 4 divided by 1 plus 4 raised to 2x. This is final answer. This is final answer. You can replay the video and learn it from scratch. Okay, right from the beginning you can see this. Very important and very interesting problem. Okay. So now what you will do is you will solve this problem where you will have to write e raised to minus x as 1 upon e raised to x and then take LCM. You will solve this problem. Thank you.